Good afternoon, students. See, in the previous class, we have learned the topic ideal and non-ideal solutions. Ideal and non-ideal solutions. Can you tell the definition? Ideal solution. Ideal solution means the two component solute and solvent that obeys the Raoult's law. The two components solvent and solute that obeys the Raoult's law is called ideal solution. That solvent and solute do not obey Raoult's law means that is non-ideal solution. Now listen, now we can see the topic. You learn some points there. The deviation of non-ideal solution can either be positive or negative. The deviation of non-ideal solution can either be positive or negative. So here your first topic, positive deviation. Positive deviation. Positive deviation of non-ideal solution. Positive deviation of non-ideal solution. Understand? See the nature of deviation from the Raoult's law. The nature of deviation from the Raoult's law. So the nature of deviation can be explained in terms of, so nature of this deviation can be explained in terms of intermolecular force of interaction. Intermolecular force of interaction between them. So how we can explain the nature of deviation in terms of intermolecular force of interaction between them. Intermolecular force of interaction between solute and solvent. So listen, your first topic, positive deviation of non-ideal solution. So how we can explain the nature of deviation means, the nature of deviation can be explained in terms of intermolecular force of interaction between solute and solvent. Intermolecular force of interaction between solute and solvent. Understand? Now listen, you consider the components A and B. You consider the solute and solvent A and B. Here the intermolecular force between A and B. Intermolecular force between A and B is weaker than this one is weaker than the intermolecular force of AA and BB. So the second point, intermolecular force of AB is weaker than the intermolecular force of AB weaker than the intermolecular force between AA and BB. Understand? So now tell the first point. How we can explain the nature? The nature of deviation from the Raoult's law that can be explained in terms of intermolecular force of interaction between solute and solvent. Understand? Then second point, the intermolecular force of interaction of AB are weaker than the interaction of AA and BB. AB is weaker compared to the AA and BB. Understand? See now third point. Third point, in such type of solution, in this type of solution, here the molecules have a greater tendency. In this type of solution, the molecules have a greater tendency to escape from the solution. The molecules have molecules A and B. These molecules have a greater tendency to escape from the solution compared the ideal solution. Compare the ideal solution. So listen, here in this type of solution, the molecules have a greater tendency to escape from the solution. Molecules have a greater tendency to escape from the solution. Compare the ideal solution. Compare the ideal solution. Understand? So molecules have a greater tendency to escape from the solution. Compare the ideal solution. So from this we are telling the vapor pressure of non-ideal solution increases. Vapor pressure of non-ideal solution increases. So from this we are telling vapor pressure of non-ideal solution increases. Vapor pressure of non-ideal solution increases. And this non-ideal solution vapor pressure is greater than the sum of the vapor pressure of A and B. This one is greater than the sum of the vapor pressure of A and B from the Raoult's law. So listen, vapor pressure of non-ideal solution increases. So we are telling vapor pressure of this one increases. This one greater than the sum of the vapor pressure of A and B from the Raoult's law. Understand? This deviation only we are telling positive deviation. This deviation is called positive deviation. Understand? So what are the points we learned? Tell the points one more time. First point, the nature of this positive deviation can be explained in terms of intermolecular force of interaction between solute and solvent. Tell the first point. The nature of this deviation can be explained. How we can explain this nature? In terms of intermolecular force of interaction between solute and solvent. Then second point, consider a component A and B. Here the force of AB is weaker than the force of AA and BB. Then third point, the molecules have a greater tendency to escape from the solution. Compare the ideal solution. So we are telling next point, vapor pressure of non-ideal solution increases. Vapor pressure of non-ideal solution increases and vapor pressure of this non-ideal increases greater than the sum of the vapor pressure of A and B. So vapor pressure of this one greater than the sum of the vapor pressure of A and B. This type of deviation we are telling positive deviation. This type of deviation is called positive deviation. Understand? And we can tell the formula. You know the formula Raoult's law. Raoult's law formula is PA is equal to PA naught into XA. You know the formula Raoult's law. PA is equal to PA naught into XA. Here we learn vapor pressure of this non-ideal increase greater. So we are telling the we can tell the formula PA greater than the PA naught into XA. Same way we can write the formula PB. So how we can write PB? PB is equal to PB naught into XB. And this vapor pressure of this one is greater. This vapor pressure of non-ideal greater than the sum of the vapor pressure of A and B. So how we can take the sum of these two? So you can add this vapor pressures PA plus PB. This one is greater than this PA plus PB is greater than add these two values. So how we can add PA naught into XA plus PB naught into XB. Understand? You got the total formula PA plus PB, that you can write P total. P total greater than the PA naught into XA plus PB naught into XB. Understand? So this one only we are telling positive deviation. The total pressure is greater than the sum of the pressure of components A and B. Understand this? See, here we can consider one simple example. You consider the positive deviation solution of ethyl alcohol and water. You consider the example, a solution of ethyl alcohol and water. Solution of ethyl alcohol and water. See, here we can tell the point, first point, the interaction of ethyl alcohol and water. The interaction of ethyl alcohol and water, this one is greater than this interaction is not greater. First you know, already we learned the point, this interaction of AB is weaker than the interactions of AA and BB. Interactions of AA and BB. So here we can tell the point. The hydrogen bonding interactions of ethyl alcohol and water. This one is weaker than the interaction of ethyl alcohol and interaction of water. Understand? So tell the first point. You consider on example ethyl alcohol and water. There we can see the point. The interactions of ethyl alcohol and water are weaker than the interactions of ethyl alcohol and water. Understand? Then we can say the second point. This results in the increased evaporation. This results in the increased, we learn non-ideal solution vapor pressure increases. So this results in the increased evaporation of both components. Increased evaporation of both components. And next point, we learn the point. Vapor pressure of this solution is greater than the vapor pressure predicted by the Raoult's law. Vapor pressure of this one is, vapor pressure of this ethyl alcohol and water is greater than the vapor pressure predicted by Raoult's law. Understand? So from this we can say this process is endothermic. We are telling this process is endothermic. This mixing process is ethyl alcohol and water molecule. This mixing process is endothermic. If this process is endothermic, delta H value greater than 0. If the process is endothermic, delta H value greater than 0. Delta H value greater than 0 means just a slight decrease in the volume. Delta V greater than 0. Slight increase in the volume. Delta V greater than 0. Understand? So listen. You consider the example ethyl alcohol and water. Ethyl alcohol and water. There we can explain the points positive deviation. Tell the first point. Ethyl alcohol and water interactions are weaker than the interactions between them. Interactions of ethyl alcohol and water. Understand? Then second point. This results in the increased evaporation of the components. This results in the increased evaporation of both components. Then third point. Vapor pressure of this solution greater than the vapor pressure from Raoult's law. Vapor pressure of this solution greater than the vapor pressure predicted by Raoult's law. Understand? Then from this we are telling this mixing process is endothermic. This mixing process is endothermic. If the process endothermic, delta H value greater than 0. Delta H greater than 0 means there is slight increase in the volume. Delta V greater than 0. Understand? Now listen. We can learn some more example. Some examples. Ethyl alcohol and cyclohexane. Some more examples. Ethyl alcohol and cyclohexane. Just to mix these two components and we can explain the same points. Then second example, benzene and acetone. Benzene and acetone. Next example, benzene and acetone. Some more example, carbon tetrachloride and chloroform. Carbon tetrachloride and chloroform. Then acetone and ethyl alcohol. Acetone and ethyl alcohol. Acetone and ethyl alcohol. One more example, already we learned ethyl alcohol and water. Ethyl alcohol and water. Try to learn this all the examples. So what are the examples? Ethyl alcohol and cyclohexane, benzene and acetone, carbon tetrachloride and chloroform, acetone and ethyl alcohol and water. Understand? See, one more time we can explain the points. Positive deviation. What are the points we learned here? Tell the first point. The nature of deviation can be explained in terms of intermolecular force of interaction between solute and solvent. Intermolecular force of interaction between solute and solvent. Understand? Then tell the second point. Second point, intermolecular force of AB is weaker than this one is weaker than the intermolecular force of AA and BB. The next point, from this we can say vapor pressure of non-ideal solution increases. Vapor pressure of non-ideal solution increases. Understand? Then vapor pressure of this solution greater than the vapor pressure of this solution greater than the vapor pressure predicted by Raoult's law. Vapor pressure predicted by Raoult's law. Understand? Then we learn some formula. P total formula. PA and PB values separately we learn. P total is equal to PA naught XA plus PB naught XB. Understand? After that, next point we learnt an example. We considered an example, ethyl alcohol and water. You consider the example, ethyl alcohol and water. There what are the points we can say? First point, the intermolecular force of interaction of ethyl alcohol and water is weaker than the force of interaction of ethyl and water. Force of interaction of ethyl and water. Then tell the second point. Second point we can say this results in the increased evaporation. This one results in the increased evaporation. Then third point, this vapor pressure of this solution. Vapor pressure of this solution increases the vapor pressure predicted by Raoult's law. Vapor pressure predicted by Raoult's law. Understand? So this mixing process we are telling endothermic. If the process is endothermic, delta H value greater than 0. So delta V also slightly greater than 0. Then we learn some more examples. We can learn the example benzene and acetone. Many examples are there. Try to learn all the examples. Understand this? So this one only positive deviation of non-ideal solution. Positive deviation of non-ideal solution. Understand this topic? See now the second topic, negative deviation of non-ideal solution. Negative deviation of non-ideal solution. Almost just oppositely we can tell the points. First point, the intermolecular force between solute and solvent. The intermolecular force of A and B are stronger than their positive we learn are weaker than the AA and BB. Here this one is stronger than the intermolecular force of AA and BB. So tell the first point, intermolecular force between Sol AB are stronger than the intermolecular force between AA and BB. Understand? Then tell the second point, almost all the points, just oppositely we can say, points are same only. Second point, the escaping tendency of molecules. The escaping tendency of molecules are lower. Their escaping tendency greater. So here molecules escaping tendency lower. Molecules escaping tendency lower. So escaping tendency of the molecules lower. Escaping tendency of the molecules lower. Compare the ideal solution. Compare the ideal solution. So from this we can say vapor pressure of this solution. Vapor pressure of this solution will be lower than the sum of the vapor pressure predicted by Raoult's law. Sum of the vapor pressure predicted by Raoult's law. Understand? So what are the points we learned? Tell the first point. Intermolecular force of interaction between AB are stronger than the intermolecular force between AA and BB. Then tell the second point, the molecules escaping tendency lower. The molecules escaping tendency lower. Compare the ideal solution. Then third point, vapor pressure of this solution lower than the sum of the vapor pressure predicted by Raoult's law. Understand? So sum of the vapor pressure of A and B. So this type of deviation only we are telling negative deviation. So this type of deviation is called negative deviation. Understand? So now here we can explain the negative deviation formula. Negative deviation, PA is lower than the, there we learn greater, but here lower. So PA is lower than the PA naught into XA. Same way PB we can write PB is lower than the PB naught into XB. PB naught into XB. So we can write total. Total also you can write P total is lower than the PA XA naught plus PB XB naught. Understand? The next point we can learn on example. Just we can explain on example. Consider the example. Solution of phenol and aniline. The solution of, consider the example. Solution of phenol and aniline. Here the same points we can explain. So tell the first point. First point, the intermolecular force of interaction of phenol and aniline are stronger than the force of interaction of phenol and aniline are stronger than the intermolecular force of interaction of phenol and aniline. Understand? Understand? Then tell the second point. Second point we can say molecule escaping tendency lower. Molecule escaping tendency lower. So result we can say vapor pressure of the solution less. Vapor pressure of the solution less than the vapor pressure of A and B. Vapor pressure of this solution less than the vapor pressure of A and B. So here vapor pressure of phenol and aniline. Understand? Then next point. Third point we can say, from this we can tell the process. Here the process is exothermic. The positive deviation we learned the process endothermic. But here the process is exothermic. If the process exothermic, delta H value less than 0. Delta H value less than 0. So just there is decreased volume also. Delta V less than 0. Delta V less than 0. Understand? And we can learn some more examples of negative deviation. Some more examples of negative deviation. What are the examples? First example, acetone and chloroform. Acetone and chloroform. First example, acetone and chloroform. The next example, chloroform and diethyl ether. Chloroform and diethyl ether. Then one more example, chloroform and benzene. Chloroform and benzene. Understand? So this one only negative deviation. So what are the points we learned? Tell the first point. Intermolecular force of interaction between AB are stronger than the intermolecular force of interaction between AA and BB. Then tell the second point. So the molecules escaping tendency lower. Molecules escaping tendency lower. Then third point we can say vapor pressure of the solution lower than the vapor pressure of component A and B predicted by Raoult's law. This type of deviation name we are telling negative deviation. So we can write the formula, P total formula. And consider an example, phenol and aniline. There just explain all the points. First interaction, then vapor pressure, then the process. Understand this? Now take page number 46. Page number 46, a non-ideal solution, positive deviation from Raoult's law. Separately learn this two topic, positive and negative. Separately learn this question like 5 more topics. So learn this topic thoroughly. So first positive deviation means, mark this one. The nature of deviation from the Raoult's law can be explained in terms of intermolecular interaction between solute and solvent. Then second point, consider a components A and B. This AB are weaker than the AA and BB. Then third point, here we are telling Molecules have a greater tendency to escape the solution. Compare the solution formed by A and B. So here almost this AA and BB are similar. And we are telling vapor pressure of non-ideal increases. So it is greater than the vapor pressure of A and B predicted by Raoult's law. So this type of deviation only we are telling positive deviation. And we can explain this formula, P total formula. Then just consider an example and explain all the points. See the first point, the interaction between ethanol and water is weaker than the interaction between themselves. The next point, this results in increased evaporation. Then third point, vapor pressure greater than the vapor pressure predicted by Raoult's law. The next point, from this we are telling that process is endothermic. So delta H mixing greater than 0. The same way delta V also slightly increases greater than 0. Then this examples of positive deviation. Learn all the examples. Understand? Just mark till this here. Till the example ethyl alcohol and water. Positive deviation. Understand this? Then same way page number 47. Page number 47 negative deviation. Negative deviation from this. Let us consider a case where the attractive force between solute and solvent, this AB are stronger than the AA and BB. Then second point, just oppositely we can tell the points, escaping tendency lower, compare the ideal solution. Then vapor pressure of this one lower than the vapor pressure of A and B. This one only we are telling negative deviation. And we can write the formula. Then consider this example, phenol and aniline. Here also we can explain the same points. First the interaction stronger. Then second point, vapor escaping tendency lower. Then vapor pressure of this one lower than the vapor pressure predicted by Raoult's law. Then process exothermic. And we can say delta V mixing less than 0. Same way delta H mixing less than 0. Understand? Then page number 48. Just mark this examples also. Acetone chloroform diethyl ether, acetone aniline and chloroform benzene. So just mark till this benzene. So these two topics important, positive deviation and negative deviation. Non-ideal solution means two deviations, positive and negative deviations. Understand? Okay, listen. Now the next topic. Factors are responsible for deviation. Factors are responsible for deviation from the Raoult's law. What are the factors means? There are different factors. First factor, solute-solvent interaction. The first factor, solute-solvent interaction. So tell the first factor, solute-solvent interaction. Solute-solvent interaction. So here the solute-solvent interactions AB and AA and BB. The solute-solvent interactions AB and AA-BB are similar. AA-BB are similar. So these interactions are similar. If these interactions are dissimilar, suppose if these interactions are dissimilar, there is a deviation from ideal behavior. If this one is dissimilar, there is a deviation from ideal behavior. Understand? So tell the first factor, solute-solvent interaction. Solute-solvent interaction. Here the solute and solvent AB and AA-BB, this one is similar. Suppose if these interactions are dissimilar, there is a deviation from ideal behavior. Understand? Then second factor, dissociation of solute. Here your second factor, dissociation of solute. Dissociation means breaking. Dissociation of solute. When a solute present in a solution, for example, you consider a solute potassium chlorate. So when a solute present in a solution dissociates to give constituent ions. that dissociates to give constituent ions. So when a solute present in a solution dissociates to give constituent ions. Now this ions interacts with the solvent. This ions interacts with the solvent. This ions interacts with the solvent. So this one causes deviation from Raoult's law. This one causes a deviation from Raoult's law. Understand? The same example only. Potassium chloride only solute. So this one dissociates to give K plus and Cl minus. Now this one interact with the solvent water. So this one causes deviation. This molecules causes deviation. Understand? Then third factor, association of solute. Third factor, association of solute. Association means joining. So association of solute. Association of solute. Association of solute molecules also causes deviation from ideal behavior. This molecules also causes deviation from ideal behavior. So you can consider on simple example acetic acid. CH3 COOH, C double bond OH. The same way one more molecule we can write CH3 C double bond OH. We can write this O1H. So this one only association of solute. This association of solute molecules also can causes deviation from ideal behavior. Understand? Then fourth factor we can study temperature. Fourth factor, temperature. Here listen, if the temperature increases, already you know kinetic energy of the molecules also increases. Temperature increases, kinetic energy increases. So there is a decrease between attractive force. So if this two increases, attractive force decreases. Attractive force decreases. If this attractive force decreases, here also there is a deviation from ideal behavior. There is a deviation from ideal behavior. Understand? Then fifth factor, effect of pressure. Effect of pressure. If the pressure molecules high, if the pressure increases, here the intermolecular attraction increases. Here the intermolecular attraction increases. Pressure increases and the force of attraction increases means here also there is a deviation from ideal behavior. There is a deviation from ideal behavior. Understand? Then one more factor, last factor, effect of concentration. Effect of concentration. If the solution is dilute, if your solution is sufficiently dilute, there is no solvent-solute interaction. There is no solvent-solute interaction. See, if your solution is dilute, there is no solvent-solute interaction. Reason, dilute means here the solute molecule number is less. Number of solute molecules are low. Compare the solvent. Number of solute molecules are low. Compare the solvent. Suppose if your solution is concentrated. If your solution is concentrated by adding solute. If your solution is concentrated, there is a solvent-solute interaction. This also causes the deviation from ideal behavior. Understand? So concentration, if your solution is dilute, there is no interaction. If your solution is concentrated, there is an interaction. Understand? So what are the factors we learned? Tell the factors. First factor, solute-solvent interaction. Here the solute and solvent interactions are similar. If it is dissimilar, there is a deviation from ideal behavior. Then second factor, dissociation of solute. Solute molecule dissociates to form constituent ions. Now this one interact with the solvent, causes deviation. Then association of solute. This association also causes a deviation from ideal behavior. The next, temperature. Temperature increases means kinetic energy increases, so attractive force decreases. So there is a cause of deviation. Then pressure increases means attractive force also increases. This causes a deviation from ideal behavior. And last, concentration. If your solution is a dilute, there is no solvent-solute interaction. Reason, number of solute molecules low. But if the solution is concentrated, there is a solvent-solute interaction. Understand this? See, now take page number 48. Page number 48, mark the topic. Factors responsible for deviation from Raoult's law. Note the topic fully. First, solute-solvent interactions. These interactions, the AB and AA and BB are similar. Expected to be similar. If it is a dissimilar, there will be a deviation. Then second topic, dissociation of solute. When a solute present in a solution dissociates to give constituent ions, this one interact with the solvent, causes from Raoult's law. And just write this example. Example, page number 49 first. Then association of solute. This also causes a deviation from ideal behavior, and write this example, acetic acid. Then temperature. Increase in temperature, kinetic energy increases, so force of attraction decreases. So we are telling deviates from ideal behavior. Then pressure. At high pressure, there will be increase in their intermolecular attraction. So this one deviates from Raoult's law. The next, concentration. If a solution is a dilute, there is no solvent-solute interaction. Reason, number of solute molecules are low compared to the solvent. If it is concentrated by adding solute, there is an interaction. The interaction becomes significant. This causes a deviation from Raoult's law. Understand? Just note the answer. Till this a deviation from Raoult's law. Understand this? Okay, now note the next day's homework portion. Homework portion, the today's topic fully. Positive deviation, page number 46. Positive deviation. Page number 47, negative deviation. Then page number 48, factors responsible for deviation. Learn these 3 questions thoroughly. Almost these 3 topics are important 5 mark questions. Learn these topics thoroughly. Understand? Okay, thank you.